Yes, thank you for attendees for participating in this talk. In this talk, we want to talk about semantic kernel and GenAI in our distributed application. And here also I used the spiral as well because it makes our development easier as well. It makes the development easier in this distributed system as well. As I mentioned, I'm Mehdi Hadeli, and I'm open source maintainer and software architect. You can reach me in GitHub, in my blog, and in my LinkedIn. I'm also Microsoft MVP for 2 years, and yeah, that's about me. Let's start our explanation. Yes, semantic kernel. What's a semantic kernel? Semantic kernel is actually like a middleware between your application and AI models, you know, and it's like a lightweight SDK, open source SDK from Microsoft, and it developed by Microsoft for different languages like C#, Python, and Java. You can develop different agents and different plugins for communication between your application and AI models. It's like a middleware. And if you want to change your models, your LLMs, you can change it without any worry. And you can change it to from, for example, ChatGPT to, for example, Anthropic models, and without affecting your existing code base. Yeah, that's the, for example, physiology of this semantic kernel SDK. Yeah, one of the main things in the semantic kernel is the kernel. Kernel is the central part of the semantic kernel. It actually orchestrates and manage dependency for our semantic kernel SDK. For example, it manages our services dependencies for AI services as well, for example, application services. Also, beside of the services, we need some plugins. Plugins like, for example, when your LLM need to call your code base or external, for example, third party, when you use some MCP or A2A, we can use plugins and, for example, function calls, and your LLM can, for example, call your code base or external one. That's the usage of the plugins in the semantic kernel, and it's very important. And that's it. It's like a brain for your semantic kernel SDK. Yeah, semantic kernel has yeah, also about semantic kernel components. Semantic kernel has a lot of components, and here I just mentioned some of the important ones, like AI service connector. We use mostly chat completion and embedding generator. Chat completion is for communication with, for example, AI models like, for example, GPT models, or, for example, Google, for example, AI models or Anthropic models. And we can have a history, chat history, for example, back and forth, request and response to reaching our goal. That's the main goal of chat completion. Yeah, it's based on different providers like Azure, for example, Google, and a lot of providers. They support as well in the semantic kernel SDK. Embedding generator also is used for example, vector database mostly for semantic, for example, understanding your, for example, concept. Mostly we use embedding generators for generating some vectors, and mostly we use vectors for semantic search or something like this. And also another component in the semantic kernel is vector store connector. Vector store connector like, for example, Qdrant, like SQL Server, for example, connector for storing our vectors, MongoDB for storing our vectors, and Postgres, and a lot of other connectors. All of these connectors support by semantic kernel, and you can use them based on your needs. Mostly, I prefer to use Qdrant because it has a lot of features and very good to use. I think it's better, for example, vector store to use currently, and I'm very happy with to use it. And in our sample also we use Qdrant as well. Yeah. Another components is function and plugins. As I mentioned before, plugins is one of the important parts for your semantic kernel components because your LLMs, your models can use these plugins. Plugins like a container for example, organizing your functions. It's like a class. You have some method inside of this class. You can assume this plugin like a class and some methods, internal methods. These internal methods like a are like a functions, and plugin is like a class, and it organize your function, and LLM can call your functions or function via function calls based on, for example, deciding LLM which function should use currently. And yes, as I mentioned, you can call this function automatically or manually. It's based on your configuration. You can configure, for example, calling this function automatically by deciding LLMs, or you can call this plugin functions manually in your code base. But I prefer to use my automatic approach because it's more flexible. Another things is yes, about functions. We have different type of functions. Native functions is like in your application you have some functions inside of your plugins, and for example, LLM can call your internal functions, actually your application code. It's like a communication between LLMs and your internal application code, and it can be helpful many times. Another thing is semantic functions. Semantic functions is mostly used for template-based, for example, prompting. You can create a prompt, and you can call this prompt like a function and get a response. But mostly we should use this function for semantic, for example, related things, not other things. Mostly semantic related concepts, we can use semantic functions. Another thing is external services. When you want to call external functions, for example, in another microservices or external provider, third-party provider, you can use MCP for calling this endpoint and getting the response. This is also do with function call inside of your plugins. Yes, another important function is prompt templating. In the semantic kernel, you can design a prompt with some placeholders and, for example, some function calls inside of your template, and all of these managed with semantic kernel templates. And also, semantic kernel support using handlebars for advanced usage of templating. You can use this advanced feature of handlebars if you want. Yeah, that's basic feature of semantic kernel components. We can go ahead. Yes, semantic kernel agent framework. It's very important currently. Semantic kernel has an agent framework for working with agents. Agent is like an autonomous program to perform tasks in a inside of a circle. We can preserve, plan, and act, and this is like a circle, and we can repeat until reaching our goal. And if we want to explain these steps, we can, for example, explain preserve like a, for example, our agent can gather information from, for example, input prompt from the user. It can gather information from input prompt, and after that, it goes to plan stage. It's like brain phase for example, AI agent. We can or agent can analyze the input, the prompt from the user, and decide what this agent should do based on internal instruction of this agent. And after that, after decision, which step is best for the next, agent can do some act. Act is like a execution part. You can execute actual plans. In the plan part, we, for example, provide steps, the plan that we want to run, and in the act phase, we run this step one by one. and execute this step in your plan. Yeah, this is about act step in the semantic kernel circle, for example, for our agents. Yes, semantic kernel also has some orchestration for their agents. We have different type of orchestration like concurrent, sequential, group chat, and handoff. These are basic and most used feature of agent orchestration. In the concurrent mode, concurrent orchestration mode, we get input prompt from the user. And after that, if we have some agents, for example, each of these agents get this prompt from the user and do this, they work separately, autonomously. And after that, or agent, or for example, orchestrator gather this result from different concurrent agents, and we can use this result concurrently after aggregation parts and use them. This is about concurrent agents. We have another orchestration, for example, for agent mode. Its name is sequential. In the sequential mode, we have if we have different agents, and we have like a start and end of, for example, phase. We start with one of our agent, for example, if the, for example, task completed for one agent, for first agent, it gather, for example, the result and send the result for next agent. Next agent get this result as a prompt and do its internal action as a second, for example, agent and process internally for doing its own, for example, task. And after that, it gathered the result and send it for next agent if we have the next agent. It's like a, like a step or by order from first to end. This is the goal of sequential agent. Also, we have another type of orchestration, which is group chat. In group chat, we have different agents, but we have also a manager. The default manager is in semantic kernel is round robin. It's like a sequential one, but we have a loop. If we reach to the end of our loop, we if we configure or, for example, orchestrator to continue after that, we can, for example, specify the invocation number. For example, if we, for example, specify invocation number to 10, we have 10 steps after reaching to step 3, which is end of our, for example, agent phase calling. We go to the first again, and we continue until reaching the invocation number of 10, which is the number of calling the agents. Yes, this steps is in the loop, like a sequential agent, but first, second, third, again, first, second, third, until reaching our termination goal, or for example, desired goal. This is also we can communicate with external, for example, a user and get some prompt as well in the interactive mode in group chat mode. Beside of that, group chat has a good feature. You can implement your own manager. It's very powerful. You can create your own manager and actually manage and decide which agent should call the next. Instead of calling agent one by one by order, like sequential one, which is the default one in the group chat, which is round robin, we can design or custom manager, custom orchestration manager, and it design which one is the next agent based on the rule that you defined in your manager. I will show you this group chat feature in my GenAI application, and you can see in the practice as well. Handoff is also another one. Handoff is like an orchestrator. You can define your condition in this orchestrator. For example, you can define some rules, and you can define the start agent for handoff orchestrator. After starting your first agent based on the rules that you defined in your hand of orchestrator. Hand of orchestrator manage the next, for example, agent to call. It's based on the rules that you defined in your hand of orchestrator manager. Yeah, that's about semantic kernel agent orchestration. Yeah, let's go to demo, which is my application, or actually, or GenAI application. Yes. Here, as I mentioned before, I use .NET Aspire for managing my microservices, because currently in this application, which is a light eShop application, we use Aspire, .NET Aspire for managing these services and for many things. For Aspire make it easier to you managing your services in development. Also, publishing mode make it easier. You can publish your application in the cloud or in the Docker Compose, and whenever you want to publish it, you can use different feature of Aspire to publish it to different, for example, providers. Yeah. We have different services in this light eShop application. We have catalogs. It's small microservices for managing our products. We have just one entity, which is products. We have reviews for managing our ratings and comments for this product. We have review microservices. We have recommendation microservices, which is responsible for recommendation, good product based on user prompt, user information. We also have order microservices, which is for ordering purpose. Also, we have card microservices, which is for carding, for example, adding some item to cart and finalize them in the order microservice. But here, for simplicity, we just work with catalogs, reviews, and recommendation, because in our GenAI application, mostly we work with these three services. Yes, let's start with defining, actually registering semantic kernel in our application. How we should register, for example, chat completion, embedding services, for example, infrastructure part of our application. I start with my catalog microservices because it's a simple microservices compared to other, and also it's core of our application actually. Yes, for registering semantic kernel, I have an infrastructure extension, and this extension is responsible for registering my infrastructure. And this method, add AI services, is responsible for adding AI related things. I created also another extension method, which is add semantic kernel, which is responsible for adding semantic kernel basic infrastructure things. For example, here I use simple options, which is semantic kernel option. In this option, we need main things related to our configuration. We have, for example, chat model, embedding endpoint, chat endpoint, chat API key, also embedding API key, and all the things that we need for designing and using your or semantic kernel, for example, features. Yes, that's about my configuration. And after that, we register semantic kernel actually. You can, for example, use semantic kernel with two approach. One is using dependency injection like this. You can add kernel to your dependency injection container like this. Another one is building kernel manually. You can create a builder manually with kernel builder. You can use kernel builder, for example, and kernel builder factory, I think, or something like this. And you can create, for example, kernel manually. Yes, that's about registering the kernel, but I think for modern application, for us, it's better to use dependency injection because in modern application, we want to use dependency inversion principle, and it's better to use add kernel for reaching this goal. After registering the kernel, main part of the semantic kernel, we can registering or chat completion and embedding feature, which is the some of the components for our semantic kernel. For example, for chat completion, I have a switch case. You can choose which provider you want to use. In my options, I specify I have two provider type. One is for chat, one is for embedding. We can specify which provider we want to use for chat, which provider we want to use for embedding. For example, for this session, I use Azure, Microsoft Azure AI for my provider for both chat and embedding. So uh, in my options, as you can see, I defined the provider, embedding provider and chat provider with Azure because I want to use Azure provider for chat completion and embedding provider. Yes, here in some at chat completion, we register. For example, if we pass Olama as a provider, we register Olama chat completion, which is an extension method and a separate library that you should install if you want to use chat completion with Olama. You can register it with add Olama chat completion, which is one of the components that you can use for your chat completion part. Also, the same is for Azure. You can use Azure OpenAI chat completion for registering your chat completion for Azure actually. The same is for OpenAI. You can register OpenAI related configuration for chat completion with using add OpenAI chat completion. Yes, as I mentioned, each of these chat completion has their own NuGet package. You can install this NuGet package separately. For example, we can see the NuGet package here. We need these NuGet packages. For example, here in semantic kernel part, you need these three package for using chat completion and embedding for these providers, Azure AI OpenAI provider, and OpenAI provider, and Olama provider. After installing these three new NuGet package, you can use chat completion and embedding services for these providers. Okay, I installed this package before, and we can go ahead and here I register both chat completion and the same for embedding generator. I register uh, the same Llama 1, Azure OpenAI chat embedding generator, and OpenAI embedding generator. After registering this chat completion component and embedding services component, we need to register OpenTelemetry related things because we want these telemetry things for observability purpose. After adding them here, we can use this code for adding telemetry. You can read these links related to registering related things and needed things for OpenTelemetry part. Yeah, that's it. This part is for registering semantic kernel for your application. Let's go ahead with other things that we need. For example, for catalog, we need to semantic search, and for that purpose, we need to one vector database. And this vector data for this session, I use Qdrant, and I register Qdrant database here in this extension. We can it's very simple. We can register Qdrant with add Qdrant vector store. Also, it's another new package because it's a separate connector and separate component for your semantic kernel. You should install the appropriate NuGet package. I think it's this one. Um, you can, yes, building block, no, Qdrant, NuGet package, Qdrant. Yes, the connector, this one. Microsoft Semantic Kernel connector Qdrant is responsible for adding Qdrant for your application and communication with Semantic Kernel as well. Yes, after registering Qdrant and Semantic Kernel core here, you need to registering some product vector in ingester. I will show you what is this. Let's explain one thing first. For example, as I mentioned before, we have just one product entity. It's very simple: name, description, price, image, and like this. It's a simple entity. And we have some features for this entity, for example, creating product and other things. Currently, we need creating product. After creating product, here, after saving product in the Postgres, I use Postgres as a APF core here. We need to insert this product as well in the vector database for semantic search. So here I use product vector ingester that I registered in my infrastructure before. Here I use this ingester for injecting or inserting my product inside of my vector database, and inside of this vector ingester method, we can see some logics for inserting this product as well as a, for example, vector base entity inside of this vector database, which is Qdrant currently, for example, here we get product from the input, and after that we gather some information. For example, we create a vector search content. It's a combine of some things, for example, name, price, and description, and we combine some things for full text search in our semantic search as well. And this full text search content we'll use in our semantic search as well. And also we store these related things for, also here we use embedding generator, which I get from embedding generator of semantic kernel. I get this via dependency injection, and after that we can create a embedding vector from our search, for example, input search term input. And after creating this embedding vector, which is based on some array like float array, we store this, meaning of our input, meaning of the product actually inside of this vector. And our vector database use this vector for semantic search or meaning search based on user input. It's very valuable. So in our vector database, we should store the vectors. Yeah, after that, we update our vector database, which is Qdrant, and that's it. We have a vector database, and our product will store in this vector database, and we can search based on this vector database, and we can do some semantic search or hybrid search. Okay, for example, let's go with semantic search. For example, in my search endpoint, we have a search endpoint here. We use our semantic search, for example, service for doing some semantic search. This semantic search, for example, class has some functionality, for example, for doing semantic search. For example, we have two different things, hybrid search, and another thing is semantic search. Semantic search is just search based on the input. For example, users input send off some search term. Based on this search term, we create a vector, and after that, we search this vector, this meaning, inside of our meaning database, actually, or vector database. And vector database here is Qdrant. Qdrant return us the result, actually the meaning of this search term inside of our vector database. After that, getting this search result, we should prepare some intelligent response for our customer, because we have a intelligent, for example, GenAI based application. We want to use a fancy response for our user. For this purpose, after getting the response from our database, from our vector database, we create some fancy response, good response for our customers, because we have a GenAI application. Here, after getting the response, I provide a good response with some prompts. For example, generate a good response for user based on this search term and this response that I get from my vector database. And after that, I send this prompt to my semantic kernel chat compilation for providing a good response based on this input, this prompt. And after that, after getting this AI response, I will show this AI response to the user. We can see the result here. For example, we can pass the, for example, we want to search for a product. For example, I want to search, for example, for Apple. No, first one, we should choose which search method we want to use. I want to use semantic search 2. And after search term is Apple, for example. Page number is default is good. 1. Page size is 5 is good. And calling the endpoint. And yeah, product is not found. It's better we pass a good product name. And here, let me pass a good product name, Apple Watch, for example. Yes, as you can see, or semantic search search the whole database based on both relational and NoSQL children database, vector database as well, for providing intelligent response for us, and return this response, which is Apple Watch Series 8 for our response, and we can see it here. Yes, that's about semantic search, and let's go with other services for providing more advanced things like agents in other services. For example, for reviews, I have some agents for doing review for user. For agenting part, for example, I use a semantic search agenting framework, and for setting this agenting framework, we should do something. For example, here for setup agents, we should do something. For example, here in add AI services, after registering or semantic kernel, like or catalog service is the same, because we need chat completion and embedding, not embedding, mostly chat completion for agents. After setting this add semantic kernel, we should set up our agents. I have four agents for these microservices. You can see them here. Let me, for example, here. Yes, we have language agent, review agent, sentiment agent, summarize agent. And the first one in the flow is, for example, we have different type of agent, as I mentioned before, sequential, chat group, and we have also normal agent design. For our normal agent design, we have a parent-child or orchestration. We have a review agent, and this review agent is like a container. It's responsible for managing the whole of agenting communication. Review agent is aware of other internal agents. For example, is this review agent is aware of another agent, which is language agent. For example, here I provide some prompts. For example, language agent is responsible for doing some language related things. Semantic agent is responsible for doing something related to semantics, for example, concept, semantic sentiment concept. Sorry. Another is, for example, for some functions for getting some information from our internal application, some calling method inside of our LLM and getting the response for providing more intelligent response for our users. We provide all of this communication, all of information for child agent as well here in our prompt inside of our review agent, which is our parent for communication or in, child and internal agents. This agent is very intelligent, I think, from my perspective, compared to, for example, sequential or other type of agents. Also, chat group orchestration is very intelligent. I will show you. But this type of agent also is very fine and very intelligent, I think. You can define all the things, communication with other agent here, and it's work very well. Yes, so let's go to the configuration part. As I mentioned, we should register all of our agents. For example, I have a review plugin. This review, as I mentioned, review plugin is responsible for communication with your code base with some, function call. Your LLM can call your code base for getting some information. Here, this review plugin is responsible for getting some, for example, review by product and other things. We get all this information inside of this plugin, these functions, via some function call inside of our LLM and getting the response from these plugins. And after that, our LLM or agents gather this information for providing some response. Yes, this is the plugin, and we should register all of our agents. As I mentioned, we have 4 agents: sentiment, language, review, and other things is inside synthesizer agent, review collector agent, and yes, I use these 2 agents in sequential mode. Currently, I want to show you the basic concept that I want to use a basic agent communication in the parent-child mode, and we use just uh, review agent, language agent, sentiment agent, and summarize agent. These 4 agents is we use for normal mode, normal agent communication mode. Yes, that's about registration. Also, as I mentioned, we have a services for calling our agent after registering our agent for doing some agent communication. We can use our services. Review orchestration service is responsible for communication with our intelligent agents. For example, I have a different type of agent orchestration. I have review sequential orchestrator, review chat orchestration, that I explain what is this, what is the sequential one, what is the chat group orchestration. You can read my code after this talk. I think I cannot explain all of this, but I just explain the basic one, which is uh, normal orchestrator, which is intelligent agent manager. Yeah, here for we have some features for doing this review analysis. For example, in analyze review endpoint, we have a analyze product review, and here we have different, for example, agent orchestration type: normal, sequential, and chat group. Here, I just want to show you this the normal one, simple one is which is parent and child communication between the or agents. And here we get we get let me agent response. Yes, this agent, we get this agent from the dependency injection. We get the review agent, which is our parent agent, the core one, which is parent, and some child. All of this is managed by review agent. And after that, our agent will use here and invoking the prompt, getting the, for example, input from the, for example, user. For example, after getting message, invoke message. Yeah, yeah, here. For getting message, we need to analyze this request. We get this request from the user. For example, I want to review product ID, this product ID. We provide a simple prompt here. Please analyze this review for this product, and we pass this simple prompt to our agent, and our agent, or actually or review analysis agent is responsible for providing intelligent response review for us and sending the response for us. Yeah, we can see the result here. For example, for doing analysis review in the normal mode, we can use the number 6. And after passing the GUID, which want to, for example, I want to get the review, analyze the review for this product ID. Maybe you can use product name, but here I use product ID. For example, I use this product ID for reviewing this product. I pass this review product ID here. And after that, it calls our review agent for providing a response for us. What is the review for this product, and is it, for example, a good product or not? As you can see, it's a good response from the agent. For example, this response, this product has 2 review, 5 star for 2 review, 4 star for 1 review, and we have sentiment, for example, analysis here. You can see we have sentiments. This is positive. We have other things, summarize agent, which is part of our review agent. All of these communicate together to provide this intelligent response for us. Actually, this is our review agent. All of these things is responsible for or review agent. We can provide a good prompt for communication between the agents here, and this agent is responsible for doing all the things. Also, one of the things is create kernel. When we want to create our agent, we should set up more important things is set up or or agents or trial agent here, for creating a trial agent and make them internally for this parent agent. We should use create plugin from local agent. It actually create a plugin from or another agent. I create some extension method for doing this. We can use some basic functionality in the core of SDK for creating a kernel plugin from an agent. We have a, for example, summary agent. We get this agent and convert it to a plugin, which is can used by or review plugin or parent plugin. We should convert all of our internal agent or child agent to some plugins and use these plugins as a child, for example, agent. And after converting all of our child agent to some plugins, we can add these plugins to our parent agent, which is review agent. And after that, our agent is ready for providing the response for our user. That's it. Also, we can create some cards. Sometimes we want to expose our agent outside of the world. For this purpose, we use A2A communication. For A2A communication, we need to provide some agent cards. Agent card is like a basic information of this agent. What is the name of the agent? What is the purpose of this agent? We summarize all of this based on A2A protocol and A2A SDK that I installed before, and returning A2A agent card. And after registering get agent card in part of our mapping and exposing some A2A, for example, HTTP endpoint, we can use this agent via A2A protocol in some other microservices. And here I register this agent as a endpoint, as a A2A protocol endpoint, and we can reach this A2A information via, for example, reviews. Let me show you. For example, here in the review microservices review, we can see, for example, reviews, well-known, and agent card. We can see all the information for this agent that exposed by review microservices for using by other microservices. Other microservices like recommendation can use this, for example, this A2A agent as an external agent, and they use this agent for the internal plugging for communication. And yeah, that's use it. It's like a open API, you know. We have some information here about our agents, and other agent consumer can use this information for communication. This is about agent communication protocol and A2A. Another thing is, exposing some functionality via MCP. MCP is different with A2A because MCP we just expose one functionality instead of whole of agents. In A2A communication, we expose whole agent via HTTP endpoint in another microservice. But in the MCP, we just expose one endpoint, mostly from third party or maybe other microservices, and we can consume it. For example, we can consume time MCP from other company inside of our application. But in A2A, mostly we use or being between our internal organization, maybe between our microservices. And it's very popular also. Yeah, that's it. I think I cannot go further because my time is finished. If the time allow me, I can show you other things in recommendation microservices that use MCP, consuming this A2A protocol and other things. I don't know I have time or not, but
Hi,
that's the
Mehdi.
thing.
You're
Yeah,
doing
yeah,
fine for time, actually. You've still got another 10 minutes or so. So if you
yeah,
have a few more things to show us, then
yeah, yeah.
that'd be great.
I have something to show. Yeah, yeah.
Brilliant, thank you.
Let me.
Can I
Yeah.
just say, sorry, if you show something on a browser again, would you zoom in the font there, please? It's a little harder to see the small fonts when you're on the stream.
For example, this part, Aspire.
You, yeah, anything in the browser there would be good to zoom in a little bit further. Aspire there, or
Uh-huh.
the JSON you were just showing as well when you want to point
Okay,
those
of
out.
course. Yeah, yeah.
That's,
For
that's
example,
perfect. Thank you.
yes, this is AJ, A2A, for example, endpoint in our review microservices. Here we have some information for review agent, which is the host, which is the, for example, version, protocol, the ID, the name of the agent, and other things. Some samples, for example, for using this agent, we can use this review agent in other microservices. I can show you how we can use this review, for example, A2A agent in our recommendation services. Let's show you how. For example, in the recommendation microservices, we need some registering some infrastructure as well, like other two microservices, catalogs and review. For example, here as well, we use add AI services, adding semantic kernel related things, adding HTTP MCP client. I will show you what is this. What is this? Also adding my agents. For example, here I add my agents, also my A2A agents. Here I want to consume my exposed A2A agent, which I have in my review microservices. That I want to show you how we can communicate between two agents from two different microservices. We can use A2A communication. And here we use at A2A client for communicating with or A2A endpoint. For example, here I use service discovery for finding which is the address of my endpoint in the review microservices for using this A2A protocol, like using Aspire functionality and, for example, service discovery in the .NET. And in the add A2A client, we, for example, registering the client for communication with or A2A, for example, microservices or A2A exposed, for example, agent in the review microservices. Here we have some functionality for getting this information in the via some HTTP client with actually if call or discovery endpoint that I show you. It calls this discovery endpoint for getting information for calling or review agent, for example, A2A services. And after setting this information, this configuration, For example, here we create agent async, and here we set up something based on semantic kernel, create a gateway client, and this card resolver resolve or expose gateway configuration via card in the review microservices. After consuming this information here via gateway resolver, after passing the address of this, for example, endpoint, which is review well-known agent card.json. I provide this agent pass here with some codings. And after that, after getting this card, agent client and gateway agent is ready to use, ready to communicate with our gateway server. And that's it about registering our gateway client and communicating with other server, which is our gateway server, which is reviews microservices. Yes, that's it. And after adding this gateway agent client in the recommendation microservices, we add also uh, production product recommendation agent like other registration agent that I show you in the review microservices. After also we add two things, MCP. As I mentioned, MCP is for calling some external call, some third party, for example, information or some endpoint in our application for getting some information. Not whole agent, just one endpoint and getting some information. For example, we have two MCP. One is time zone, which is external service, external MCP from MCP protocol, for example, provider, and for calculating the time. What is the time right now? What is the time of running this, for example, agent? I use this MCP client. And another one is, for example, internal application. My internal application, I want to get the product information from my catalog. For example, here I am in the recommendation microservice. I want to get some information from the catalog, but not whole agent. I just want to call one endpoint from my catalog microservices for getting information about a specific product or some specific product as an array. I use HTTP MCP client. We can use HTTP or Stadio MCP, two different approach for consuming MCP. The one is based on HTTP protocol, another is based on JSON RPC for communication with Docker, for example, execution or something like this. We use JSON RPC for communicating with some REST endpoint inside of your LLM. Actually, or your LLM is responsible for calling this client and communicating with external world, as I mentioned. This is the purpose of the plugins and function calls. Yeah, that's about registering the MCP, required MCP for calling external world from inside of our LLM. Yeah, after registering all of these things, we can use all of these things inside of our recommendation agents, which is responsible for using all of these things with some prompts. I write a good prompt, very, for example, extended prompt here, and registering all the things. For example, all of the things for registering inside of the agent should be plugin, because for communicating your LLM with external world, you need function call, you need plugins. That's it. It cannot understand what is the agent. Your LLM just need to understand the function call, functions, plugins. So we should convert all of our MCP, all of our A2A, all of our agent to plugins to function calls. So I provide some extension method for converting plugins, converting MCP tools to plugins, converting our again MCP tools to plugins again, converting MCP agent, A2A agent again to plugins again, and registering all of these things inside of my kernel, my actual agent. And after that, registering all of external agent, all of MCPs, all of internal agents, we can go ahead and use this, for example, recommendation agents. Yeah, that's it. Using all of the external MCPs, 8-way protocols, internal agents, internal function call inside of your agents for creating a good agent in your system, for creating a good GenAI application and at the end. Yeah, that's it.
Thank you very much for that, Mehdi. That was a really fascinating walkthrough of a whole lot of really cool
Yeah,
framework stuff there, actually.
my
Um,
time was very limited, but I try to show you a sample, a real world sample. I need more time for showing you how they work together, but the time is limited. I just
no,
show you the basic things. Yeah,
yeah, this is great. No, that sample looks fantastic. It looks like a
yeah,
gold mine of information. We've already
yeah,
had a few people on the chat asking if you could share the link. Is that something which
yeah.
is
Of
available to
course,
download?
yeah, of course. You can check my GitHub. For example, here you can check my GitHub.
Okay, we can't
We
see your screen at the moment. Should
we
we?
cannot see my
If you
screen.
if you want to send the link to me in the chat, I will put it on in the YouTube chat. How
Yeah,
about that?
of course. Let me find the link, and after that, I will send it for you. Yeah, this is the link. Can I send it for you right now?
Yes, you can send it to me now, and I can put it straight into the YouTube chat. No problem. And we can then. I've got a few more questions as well there. So there's a right. Let me
Yeah,
just
Mhm.
grab this, and I'll put this one
I
straight into the
sent the
chat because I
link.
know people.
Yeah,
I've
I sent
got
the
it,
link
and
for you.
it's straight in the chat there because I know people. I would also like to have a walkthrough of that. Actually, there's a lot of interesting things in there. Semantic kernel looks really interesting, but one
Hmm.
thing I didn't get in the talk there is I didn't quite understand the concept of a plugin. I get the
Hmm.
functions you can call, I get the agents, I get the MCP, but what are plugins? I didn't understand that bit.
Yeah, plugin is actually a container, like a class. You can organize related things, related functionality. For example, in a plugin, for example, you design a weather plugin. In a weather plugin, you can define some function. For example, get the current weather, get tomorrow weather. All of these are some function, but you organize all of this function inside of the plugins. Plugin is just like a organizer at the
Right.
end, at the end, LLM use the functions. It cannot understand what is the plugin. It understands just the function and function calls. Yeah, it's just
Okay.
for
So
organization.
yeah, so semantic kernel has this abstraction of a plugin,
Yeah, of
and a
course, of
function
course.
is a plugin, an MCP is a plugin, an AI,
Yeah,
sorry, an agent is a plugin. Right, right, right. That makes sense. Brilliant.
exactly,
Thank you.
exactly. Yeah,
Yeah,
exactly.
and oh, in fact, somebody just asked on the chat there, is plugin the same as function calling? And it sounds like it is.
Yeah, 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 exactly.
Yeah,
And
right.
somebody also asked
Oh,
an interesting question about, they were finding some things in semantic kernel confusing, but the general argument is why use semantic kernel if you can just, call the REST API directly, right?
You know, Semantic Kernel developed by Microsoft. You can trust them, because
That's
they
true.
have good engineer. You should not your, for example, SDK for using the AI communication because it's not safe. Also, it's not. You don't have all the feature in the semantic kernel, for example, in your SDK because semantic kernel has a lot of features. And developing all this feature for yourself is not make sense. You know, because this library maintained by Microsoft, and you can just use this good functionality, good SDK, and go ahead. And yeah, that's it.
So eventually after, typically when you use an API, it's just, you don't get all the extra bits. And then eventually, if you were to develop an SDK, you'd eventually get to something like a semantic kernel. So
Yeah,
just
of
use,
course.
right. So it
You
makes
can
more
you can
sense.
create your own semantic kernel, but it not make sense.
I mean, you
Yeah,
could, it's just going to waste a lot of
you
time.
could.
Right.
You can do anything.
Yeah, exactly.
Yeah,
mhm.
yeah.
Speaking of these frameworks, though, somebody mentioned Microsoft Agent Framework. and it feels
Yeah.
like are they in a very similar space? What's the difference between them?
Yeah, of course. Hopefully or unfortunately, Microsoft released agent framework, I think 1 week ago, and it's very similar to semantic kernel. But this agent framework internally use Microsoft extension AI as an internal, for example, chat completion and embedding services, and they create some agenting functionality very similar to semantic kernel agenting functionality like sequential orchestrator, like chat group orchestrator. We have all of these things in the, for example, AI agent framework as well. But as I understand correctly, they want to extend this new framework. I don't know why. Maybe in the future they discontinue maintaining the semantic kernel. It's not currently, but maybe in the future, because currently they maintain semantic kernel beside of the agent framework. But in my opinion, most of new feature in the future will be in the agent framework, and they try to extend this framework, agent framework, mostly compared to semantic kernel. I think agent framework, working with agent framework is simpler compared to semantic kernel, because that I work with both, and the working with agent framework is very simpler compared to semantic kernel. Maybe in my future talk, I will talk about agent framework instead of semantic kernel. Also, I migrate this sample into agent framework as well.
It would be very much interesting to see to compare the two samples, then the semantic kernel
Yeah, of
framework and then
course.
the
I will
agent framework.
provide this sample as well beside of my previous semantic kernel sample, and you can compare them. What is
Yeah,
the
awesome.
difference in the real
Hmm.
application?
Yeah. So
That's it.
does the agent framework have, based on its name, does it have more of a focus on agents, whereas semantic
Yeah,
kernel?
yeah. Just it's just focus on the agent part, not
Okay.
chat completion, not embedding part, not vector database, just agenting part. Because for communication with vector database, QDRAN, something like this, you should use semantic kernel again. And
Okay.
but for chat completion part, you can use semantic kernel, but it's better to use or switch to the Microsoft extension AI chat completion and embedding. Yeah.
Okay.
What's the use case for the vector database? I mean,
Yeah,
is it
yeah,
largely for the LLM
mostly
side or is it for the end user?
mostly for end user, for example, for semantic search and for RAG based, for example, when you want to create some
RAG
RAG application, yeah, you use vector database for semantic analysis, for semantic understanding your for example files, your data, and in this type of things, this type of related things, you can use, for example, RAG based or this thing, yeah.
Which is any particular database you recommend? I think was SQL Server going to add that functionality too, like Vector to it?
Yeah, I recommend QDRAN because it's very good compatible with .NET. It's compatible with Aspire,
Yeah.
and it has a lot of good features. It has a good UI as well. I can show you. It has a good UI, and you can uh, see the, for example, your vector
Q,
UI here, QDRAN UI. Yeah, I
yeah,
forgot
Q
before.
or Quadrant, I think what they call it, but yeah.
Yeah, dashboard. It's currently, yeah.
Yeah, I think
It's
it has
currently
integration to
launching.
Aspire as
Yeah,
well, right?
yeah, maybe. But yes, the address port is here. You can use the dashboard, QDRAM dashboard in this address, and it's very helpful, uh, like a, SSMS, but inside of the browser. You can manage your entity, add the things, view the, for example, vectors and all the things, and you can manage
Mhm.
the things in the UI. Very good.
Yeah. Should just mention as well, you were talking about RAG there. RAG is retrieval augmented
Yeah.
of generation. That was it. I completely forgot what it was for a second there. When you want to be able to add extra information into your LLM's response, isn't it? So it can go off and find extra information.
Yeah. Also, semantic kernel has good functionality, as I mentioned, for creating embedding generator, embedding part. You can use semantic kernel functionality, and after that, you can use vector database that you have via communication with semantic kernel and vector database. You can combine all of these things for creating a RAG-based application. You have all the tools that you need for creating a RAG-based application in the semantic kernel. You don't need anything else. All of the things is provided by semantic kernel. Yeah.
Mm-hmm. With the Dad was interested with the prompts that you had to put in there. So you've obviously got a number of places where you had quite extensive prompts.
Yeah,
What
it's like
happens
prompt
when you?
engineering, very important.
But I find it interesting to see prompts inside your application. I mean, obviously it has to happen, but it kind of is sometimes something you don't always think about. How do you integrate the calling of the functions, the agents, with that prompt? Do you have to have the agent information in the prompt itself?
Each agent, the core part of each agent is internal instruction, and this instruction is like a prompt. And for example, understanding how this agent should work after getting the input, how it should analyzes and provide the response, how it should communicate with external world, external function calls. You should provide all this information in your instruction as a prompt. Yeah,
So
your agent just understand the prompt, not
so
follow.
when you add a function to an agent with the plugin sort of infrastructure,
Yeah.
are there any APIs, I guess, from Semantic Kernel that will help you tell the model, the agent, that those functions, those plugins are available? Or do you have to have your prompt and that's got
Let me
everything?
show you. Yeah, let me show you. For example, in my review, let me show you review agent. For example, in the review agent, uh, shared agent, review agent. Yeah. For example, this agent need to communicate with two other agents as well. It need to understand to communicate some internal function calls. For example, like some functions, some plugins internally. For doing this, we should provide all this information inside of your prompt. If you don't provide this information, your LLM cannot understand where is this function, where is this agent. It cannot understand anything. Beside of adding this agent here, it's not helpful. You should provide minimum information here. For example, what is the language agent? What is summarize agent? What is the get
Okay.
review ID function? You should provide this information for understanding your LLM.
So you
If
add
you,
the
yeah,
you add the function or the agent as a plugin, and then you give it instructions on how to use it in the prompt.
yeah, exactly. For example, for
Right.
this get review by product ID, we have plugins here, and we register here. For example, review plugin, we have get review by ID function, get review by product ID function. We have also other things. We have this plugin, we have these functions, but you should mention these things inside of your prompt. It's very important.
Okay, brilliant. Thank you for
Yeah,
explaining that. There.
yeah,
I think a last question. We were also asked on the chat about Aspire, and
yeah.
I think I saw the dashboard there as well. Do you have what kind of integration is there with Aspire?
Yeah, of course. About Aspire, let me show you the Aspire part. For example, Aspire host. Yes, for example, as I mentioned, we have a distributed system, and for managing this distributed system and up and running this distributed system is better. Put all configuration in your app host and just easily up and running your application. So here I, for example, configure my catalog Postgres database, order review Postgres database inside of my resources for my Aspire. Beside of that, I use Redis for my card services, Qdrans for up and running Qdrans for vector database, and adding this this Qdran to resources for Aspire. Beside of that, we need add our services to resources in the Aspire. For example, catalog service, we need to register catalog, review, and other things. And also for service discovery for our clients, for example, our review API, we need to call, for example, catalog API. So we need to wait for and wait with reference for doing some service discovery magics for internal review service discovery for calling this catalog API client.
Okay.
After registering this API, also that's it. If you want to use Olama instead of Azure, for example, Azure AI, I have this configuration. You can just comment this out for using Olama, and your Aspire is responsible for up and running your Olama and up and running your models for using both chat completion and embedding. But because I use Azure AI inside of my application, I use some environment variable for getting API key and the models from the environment variable. I do not provide this information here. Yeah.
Well, that's fantastic. It looks like it sort of integrates very nicely there with Aspire and would work in the way that you understand already from Aspire knowledge, which is good.
Making running this application also very easy instead of running each of them separately. Just running Aspire.
Yeah, exactly. Aspire is a big help really for distributed systems these days. It's good. That's absolutely fantastic. It's a brilliant walkthrough there. I'm looking forward to having a look at that sample application. Just remind everybody that's in there in the chat. Mehul, did you have any questions before we wrap up?
No, that was great. And yeah, I'm looking forward to trying out that samples myself.
Yeah.
Thank you very much for your...
I sent the sample, for example, link for you in the chat, but you can check my GitHub and you can find it very, very easily. Not very hard.
It's already in the YouTube chat, and I suspect people have already started cloning it to have a look.
Yeah.
Brilliant. Thank you very much for your presentation.
Thank you.